Hello everyone, hope everyone is doing well. Today we're going to learn about two sample tests. So far we have tested hypotheses such as where we had a mu which was equal to a certain number versus a mu which was probably not equal to that number. So basically we had one sample and we tested, basically took the x bar, s bar, and n bar, or n, and we found, and then we did our hypothesis test. Now what we are going to do is we are going to have two samples. So we are going to test whether sample 1 versus sample 2 that we have here. So we will have x1 bar, s1 bar, and n1. And we are going to test x2 bar, s2 bar, and n2. And what we are testing here is not whether 1 mu is equal to a fixed number. So we're going to test if the mu and 1 of sample 1 equals to the mu 2 of sample 2, or they're not equal to it. We can also do a one-tail test, but if you want to do a one-tail test, you can watch my other videos where I do a one-tail test, but basically the idea is pretty much the same. So we're just going to introduce the two-tail tests here. Now what we are going to do here, since we have two tests, just like before when we did our one-tail test, it all depends upon whether we know the population standard deviation or not. We assume that they're equal, but unknown. In that case, the t-distribution to find our test statistics. So we will find the t-stat, which the formula is, we are going to use x1 bar, x2 bar, which are the sample means. So the formula is going to be x1 bar minus x2 bar, then minus mu1 minus mu2 divided by the square root of sp squared, 1 over n1 plus 1 over n2. This number, sp squared, is what we would call the pooled variance. What does pooled variance mean here? It's basically meaning that we don't know what the actual population standard deviation is, but we do know the sample standard deviation. So from here we know the sample standard deviations. So from that, we could basically do a weighted average of those sample standard deviations to find the population standard deviations. But here, since we are using a squared term, we're going to use the variance. So what sp squared that equals to is n1 minus 1 times s1 squared. Let's put a bar on top of it, plus n2 minus 1, s2 squared, divided by n1 plus n2 minus 2. So if you look at it, here we are, then the reason why we have minus 1 and minus 2 is that we are accounting for degrees of freedom. So after we find our t-stat, this is the formula. Now in our case, mu1 minus mu2, in our hypothesis testing, we are testing that they are equal to 0 versus not equal to 0. So this number becomes equals to 0. In effect, we're actually, we could test if it equals to 5 versus not equal to 5, but if we are testing if they're equal, then we are testing that mu1 minus mu2 equals 0. So that basically then simplifies to x1 bar minus x2 bar divided by the square root of, and then every other step is the same. After we find this, we compare this number with the t of critical value. And since it's a two-tailed test, we would have, if this is my t-distribution, I would have my t-critical value here. The lower bound is here. And the upper t-critical value is here. So this one would be a negative value. This one would be a positive value. And so if my t-stat falls here, anywhere between these two bounds, then we do not reject. But anywhere outside, like here, this is the rejection region. And so we have it. Now, another thing we have to look at is the confidence interval of that difference. So if I have x1 bar minus x2 bar, the difference is this. This is of the sample, but we also want to know what is the population difference. So the difference between mu1 minus mu2. So how can we find the 95%, 90%, or 99% confidence interval of that? So to do that, 90, 95, or 99% confidence interval, we would write it as x1 bar minus x2 bar. That's the difference. And then plus minus the t value times. And then what we have down here as p squared 1 over n1 minus 1 over n2. So these are all the formulas we need, and so let us try to implement that in Excel. Let's say we have these two samples and we want to test whether they're equal to or not. So my null would be, so those are my null and alternate, mu1 minus mu2 equals to 0, and mu1 minus mu2 is not equal to 0. So let us find the sample. We collected our sample, so let's find the mean, standard deviation. Actually, we can just go and find the variance, and we know we need our n. So the mean would be average values of all these numbers, and the mean for the other one is this. So I'm just going to copy and paste the formula for this one, and I'll just put it on the, and for variance we're going to do, since it's a sample, we will do var dot s, because it's the variance of a sample. And then we are going to just find that. And again, I'm going to copy one of the formulas and put it to the right. And then n would be my count. So I have 17 observations, and so after all that, so we have our mean, variance, and n. Now we have to find the pooled variance. So to do that, one of the things I can do is just find n minus 1. I mean, it gets a little easier to do the calculation, so I can do 17 minus 1 and 17 minus 1 for both of them. Now after that, so the formula is that. Now first thing I can do is find this part. So what I will do is write equals to 16 times the variance. That's for that first part. Then the second part is just going to be this side, which is going to be plus, again, 16 from the other sample times the variance of the second one. So we have those two. Actually, I should have put a parenthesis around it. So let me put a parenthesis around those two numbers just so that we know where they are coming from. And then the whole thing has to be divided by n1 plus n2 divided by 2. So I can do, you can do them in steps. I can do them together. So let me just complete them together. Divided by n1 plus n2 minus 2 is basically going to be, again, 16. And I should put my parenthesis in the right position so that it doesn't cause any issues. And that is going to be my pooled variance. So again, after finding the pooled variance, now I just need to find the t-stat, which is going to be, so my t-stat is that. Now let's do this in part, because doing that together becomes a little complicated. So let's find the numerator first, which is this part. So I'll write here the numerator. It's going to be x1 minus x2. Now I can take either one. If you like t-stat to be positive, you can write 81 minus 70, but it doesn't really matter because we're doing a two-tailed test. So here we really can use negative or positive. So now to find the denominator, we would need to do, first let's do the inside part. So let's first try to do this part, and then we can square root that. So I will write equal to the pooled variance times 1 over n1 plus 1 over n2. Here it's not n1 minus 1, we just need n1 and n2. So we should make sure to check those two numbers. Now we have this number, and what we need to do is find the square root of that. So I can write square root of, then my t-stat is going to be the numerator divided by the denominator, which comes out to be negative 2.74. Now I can use positive 2.74. It doesn't really matter if I wanted to write it as 81 minus 70, but since it's a two-tailed test, we can use either negative or positive numbers. Now we can find the t critical value, which is going to be equals to, let's say my alpha is 0.05, so we're testing at 5%, so it should be t.inv. The probability is 0.05 divided by 2, and the degrees of freedom is going to be n1 minus 1 plus n2 minus 1. Copy the formulas. So from here now we can see, if I draw the t distribution, I can see that the critical values of t are at negative 2.03, and since it's a two-tailed test, it's at positive 2.03. The t-stat is way out here at negative 2.74. So if this is my non-rejection region, the t-stat is outside, so we can say, since it's outside of the non-rejection region, we are rejecting the null. Therefore, these two numbers are not equal, or these two samples are not equal. Now what we can do also, we can use Excel's function to find, or to do this test. What we can do is, basically, we can go to data, and then go straight to data analysis, and then click on t-test to sample assuming equal variances. We can click on that, and I will pick my sample 1. I put the name in there too, so that it's easier to have them labeled. And then I pick the second one too. My hypothesized mean difference, this is always going to be 0, because that's what I'm testing here. And I do have labels, so I'm going to click on labels. My alpha is 0.05, and I want to put my output, let's say, right here. And then I get my results. So if I look at my results, if I compare them with before, I see those are my numbers. That's my mean. I have my means down here. My variances are here. My pooled variance is here. I have my t-stat, which is down here. And the critical value of t for the two-tailed test, that is right here. So from here, we can also find that we reject the null. I can also find the p-values for this. So if I actually did the t-stat to find the p-value, I could do t.dist. I can do 2t. X would be my t-stat. Degrees of freedom would be 16 plus 16. I guess we need this to be a positive number. So we get 0.0098, which is, the formula for this is going to be this. Notice I put a negative value here. As you notice right here, the reason I put a negative value in front of the t-stat, it's because so that this becomes a positive, and Excel needs a positive t-value in order to calculate the p-values. All right, and now let's look at how can we find the 95% confidence interval. And we wrote the formula already. So this is our confidence interval. Now we do have the numbers here, so let me just move this down here. It would be easier. And now what I can find is the first part, which is x1 minus x2, that is going to be just, so to calculate this part will be just going to be 70 minus 81, which we find out. The t alpha over 2 that we have, this is the critical value, so this number is actually going to be right here. And this number is p squared times 1 over n1 plus 1 over n2. This number is actually going to be the denominator that we have from our values that we calculated when we calculated the t-stat. So now I can find the margin of error, which is going to be the t critical value times that denominator that I calculated before. So it is, let me just put a negative in front so that our margin of error comes out to be positive. Lower bound, negative 11 minus the margin of error, and the upper bound going to be negative 11 plus the margin of error. So now we can say that we are 95% sure. So we can now say we are 95% confident that the difference between the two population means is between these two numbers. This was for the variances are being equal. What if the variances are not equal? For that, we have to use another formula. It is a little difficult to do this by hand, so I'm just going to use the Excel's formula or Excel's pre-canned program to run this program. So I'll go straight to data analysis, and then I'll go to t-test 2 samples assuming unequal variances. So we click on that. My variable 1 range is going to be the sample. Variable 2 is also the same thing. The hypothesized mean difference will be 0. I have labels. My alpha is 0.05, and I want it to be, let's say, right here. And then when I run it, this is what I get. So here I find everything else is the same. Your mean variance. You don't have a pooled variance here. The t-stat comes up. In this case, coincidentally, the numbers, the t-stat, are exactly the same. But usually it may not be the case, so it's better to run them. If you believe that the variances are equal, then you run this test. If it's not equal, you run this test. And we do see that the t-stat is greater when the absolute value of the t-stat is greater than the critical value of t, so we also, in this case, reject the null. Hopefully this was helpful, and I will see you at a later video. Have a good day. Goodbye.